Okay, we found volume with known cross-sections using the area of geometrical shapes, integrating the area to find volume. Another way to find volume of a curved shape is through revolutions, when it's revolving around a horizontal or vertical axis. So if we have the function y equals e to the x, the exponential function that's increasing over time, and we revolve around the x-axis, which has an equation of y equals 0, then we get this solid cone shape that we see here. If we go from the x-axis up to the function, that would be the radius of the circle you see here, the height of the function, is the radius. So this is called the outer radius. So I should label that capital R. And the inner radius in this case is 0, y equals 0. Here's the equation right here. We don't come up from the axis at all. So the equation to find the volume when revolving around a horizontal axis well, we're going to integrate the area of the circle. And the area of a circle is pi r squared. From the lower to upper bound, smaller to bigger number. A vertical axis of revolution, revolving around a vertical line, such as the y-axis, which has an equation of x equals 0. Well, then we use the y's for the boundaries. We go from C to D. And the radius of this circle is the height out to the function from left to right. The distance out to the function is r sub y. The radius in terms of y, not x. We're studying these y values and not the x values. And dy tells us that our boundaries are in terms of y. We're going from the lower number c to the higher number d on the y-axis. dy and dx tell you which axis this function is moving with respect to. So let's do an example. So let R be the region enclosed by the function f of x equals x squared minus 1, the horizontal line y equals -4, and the vertical lines x equals 0, in x equals 4. Find the volume of the solid generated when the region R is revolved about the line y equals -4. So it's rotated around this line, this horizontal line, y equals -4, so it's rotated around the yellow line. Use a calculator to find volume, so we need to set this up. So we're going to go from 0 to 4 along the x-axis. We know that much. Since the region R is completely adjacent to the axis of rotation, we can use the disk method, where the radius is the distance from the axis of rotation to the function. So the radius is the distance from the axis to the function. From the axis to the function. So we need to get from the axis to the function. We need to get from the yellow line to the green line. We needed to be able to do that all the way across from 0 to 4. Well, at any given moment, that height is going to be 4 units to get up to 0, and then f of x. The function f of x is equal to x squared minus 1 so to do the outer function minus the inner function, the top minus the bottom to get the height. And the height is what equals the radius. So we need to integrate the area to find the volume. The area of a circle is pi r squared, and the radius is x squared plus 3. So from 0 to 4, we pull pi out front because it's just a number. We need to square the radius. The radius is x squared plus 3 in terms of x. And now we can use our calculator to type this in. Round to 3 decimal places, we get 1,158.619. Volume, if we had the units. Alright, let's do another example. Let the region R be the area enclosed by the function f of x equals root x minus 1. That's f of x. The horizontal line y equals 1. Y equals 1. And the y-axis. Okay, so these two functions meet. Go to the point of intersection. Start at x equals 0 and end at what looks like 0, 4, 1. Would be the intersection of these two functions. Here. Find the volume of the solid generated when the region R is revolved about the line y equals -3. So it's not revolved around the x-axis. It's moved down to the line -3. So we need to integrate the area to find the volume, but here we have a different shape. We know it intersects at the point 4,1. Since the region R is not adjacent to the axis of rotation, we must use the washer method. So adjacent meaning like touching, near, next to. This region is not on touching this line y equals -3. We're going to revolve it around something that's not touching. So the area of the washer means outer minus inner. We take the outer radius minus the inner radius. So we have pi r squared minus pi r squared. We're taking a circle minus a circle. So we're subtracting out the inside area that's not there. So we're taking the outside area minus the inner area to subtract out the dead space in between to find the volume of this object that would be like a bowl with no bottom. So the radius is the distance from the axis to the function. So to the further function, r, capital R, we're going up 3, and then to the function, which is y equals 1. So 3 plus 1, this is 4. Since we're going out to a straight line, the outside of this bowl will be smooth, not curved. So our outer radius is the outer minus the inner, 1 minus the -3, which is 4. And the inner radius will be the same 3, but now we're going to go up to f of x. So it's going to be 3 plus f of x, or f of x minus -3. F of x minus 3 minus -3 leaves us with root x plus 2. So to integrate to find the volume, integrate area to find the volume, so we have pi times the integral from 0 to 4 of 4 squared minus the inner radius in terms of x round to 3 decimal places. And one more. Find the volume of the solid obtained by rotating the region bounded by x equals y 2 minus y squared. So that's something of degree 2. So that's a parabola. It's x in terms of y. So it's this parabola. X equals -y, that's a line. and the line x equals 3, which is vertical. And the y boundaries come from the point of intersection. Okay, so it's going to be this purple region revolved around that yellow line all the way around. So again, it's going to look like a bowl. The outside is going to be smooth, the inside is going to be curved. It's also going to have a hole in the middle. So now we're in terms of y, we're going from this bottom point to this top point. We're not going left to right. That's y equals -1 and y equals 2. So going from y equals -1 to y equals +2, the outer radius, again, from the line of revolution to the function. So from x equals 3 to x equals 2 minus from x equals 3 to the straight line x equals -y. It's 3 minus -y, which simplified as 3 plus y. And the inner radius is going from the line of revolution to the parabola, so 3 minus x, which equals 2 minus y squared. So 3 minus 2 is 1 minus y squared. So the volume we find by integrating the area of the outer circle minus the inner circle. This is plus y squared. Get 73.513. So you might be thinking, how can I just sub in x and not y and nothing change? Well, x in here is just one variable. That's just standing for one variable. Y in here, in this case, again, is just one variable. So you can use x equals for any variable, x, y, or the third dimension, z. And that concludes our lesson on volume. When the shape is revolved around a vertical or horizontal line.